Okay, Chapter 3, Day 3, the first derivative test. So in Day 1, we determined absolute extrema. Absolute extrema can occur at critical numbers or endpoints, and absolute extrema represent the y value larger than all other y values on the domain of the function. And absolute will not necessarily be asked for. When you're just asked to determine extrema, it's known that you're looking for the absolute extrema. Okay, so today we're looking at determining relative extrema. So relative versus absolute. So again, absolute is the biggest y value on the function. A relative or local extrema, and we talked about this with the intro worksheet, represent turning points on the graph of the function. A relative maximum is what we would refer to as a hill on the graph, and that's where your function changes direction from increasing to decreasing. So yesterday we looked in class in determining intervals where the function's increasing and decreasing. Now those specific changes in direction tell us about our relative extrema. A relative minimum would look like a valley on the graph, and that's where your function changes from decreasing to increasing. So relative extrema, again, they're turning points, and where do the turning points occur? At a change in direction. Okay, important theorem here. If a function has a relative extrema at some value c, then c is a critical number of f. Now the converse of that is not necessarily true, and we'll talk more about that in class. But attempt to write what the converse of the theorem is, and then we'll talk about that in class. So again, if a function has a relative extrema, then it occurs at a critical number. That value is a critical number. And where do the critical numbers occur? Where the derivative of the function equals 0, or where the derivative of the function does not exist. Okay, so the first derivative test, this is used to locate the relative extrema of a function. So recall your absolute extrema. Okay, let's see. So absolute extrema, that was find your critical numbers, evaluate the function at the critical values, evaluate the function at the endpoints, and then draw your conclusion. So to determine relative extrema, complete the steps to determine the intervals of increasing and decreasing. That's what we did. We looked at on day 2. Now we look specifically at the sign changes that we have represented on the number line. So I have my labeled number line. A change in sign on the derivative tells you a change in direction on the function. So if your derivative switches from positive to negative, then where that switch occurs, a relative maximum occurs on the graph of the function. All right, your derivative changes from positive to negative, which tells you your function changes from increasing to decreasing. If there's a sign change from negative to positive, then at that critical value, a relative minimum occurs. And again, look at the y values. They are the y values of the function. Your derivative switches from negative to positive, and therefore your function switches from decreasing to increasing. If you do not have a sign change, then no extrema occur. And that's a valid case as well. Okay, so I'm using all the examples from yesterday, and I've kept the number line with the signs that we determined in the notes for day 2. Use the first derivative test to determine the relative extrema. So we have our function here, Again, the steps are go through the same steps that you would determine where the function is increasing or decreasing. So that's your critical numbers, alright, this is labeled number line, and then determine the sign of each interval. So we've done these three things on the day 2 notes. So now, what does the behavior of the derivative tell us about the function? If the derivative is negative, we know the function is decreasing. And I like to do number lines for both of them because I think it helps you with your visually. If the derivative is positive, then the function is increasing. So now what does the first derivative test say? A relative minimum occurs at x is equal to -7 and y. And you have to justify, and we've talked about this, you have to justify if you're going to use the number line. So a relative minimum occurs at -7/2 because the derivative switches from negative to positive. Now, what is the relative minimum? Absolute max and mins or y values, well, relative max and mins or y values as well. So to determine the relative minimum, we take the critical number where the sign change occurs and plug it back into the function. So you can verify that the y value, okay, -7/2 squared plus 7 times -7/2 plus 10. So where does it occur? It occurs at the x value. What is it? The relative min is -9/4. Okay, next we had, I'm just realizing now, these variables are off. We had our trig function. This is the sign of the derivative. So what does that tell you about the behavior of the function? Derivative is negative, therefore function is decreasing. Derivative is positive, therefore the function is increasing. Derivative is negative, therefore your function is decreasing. Alright, so we have a relative minimum at x is equal to pi/3. Again, a quick justification because the derivative switches from negative to positive. And we have a relative maximum at x is equal to 5 pi/3 because the derivative switches from positive to negative. Oops. Switches from positive. So what are the relative max and min? The relative minimum. I'm sorry for the delay.
Love you.
The relative minimum, plug pi/3 back into the original. and you can verify that you get pi over 3 minus square root of 3 and your relative maximum. Plug 5 pi over 3 back into the original function and verify that you get pi over 3 plus the square root of 3.